All right, so I'm not here today. I'm out sick today. But what I want you to do, we'll talk about your weekends on Monday or Tuesday, excuse me. Yeah, I hope you guys have a great long weekend. Um, but I'm not here. So what I want you to do is I want you to try this word problem. Okay, I want you to find the length of SM, and I want you to think about whether or not these two triangles are similar. Okay, and if they are similar, like what makes them similar? What makes them similar from what we talked about yesterday? So go ahead and pause the video and try to find SM. Okay, so we could have set this up a couple different ways. I could have said, I could have used the way on the left or the right. Now, here's the deal. I could have also said that like 15 over x equals 9 over 12. That would have worked as well. Or 10 over x equals 6 over 12. Remember, we can solve these in many different ways, but no matter what, you should get x to be 20 by cross multiplying. Okay? For this next part of the lesson, I want you to play around with this if you can. Try to make some sense of it. What you're going to do is you're going to go to Schoology, okay? You go to Chapter 8. You're going to go to 8.2 class link, all right? And what I want you to do is I want you to write down the measurements here. It's probably easier to open this in a new tab just like this. All right, what I want you to do is I want you to write down the measurements here of these angles and the side lengths here, okay? And to find the ratio of these sides, remember ratios can be written as colons or can be written as fractions. So what I'm going to do is divide AC by DE and divide these two and divide these two. And we'll see if the relationship between these three. Okay, and step number 2 says to adjust the slider for trials 2 and 3. So I'll just play around here, adjust this, and see what happens. All right. Why don't you go ahead and pause and try that? If I'm not mistaken, I remember at least our initial trial, the ratio of our sides was 1.03. If you notice, you should notice that all of these ratios are going to be the same. And no matter what, these angles here and here will be congruent. All right, so remember, if you remember from yesterday, we talked about similar figures. We talked about the ratios of their corresponding sides being equal and the corresponding angles being congruent. Okay, so what we're doing today is we're proving similar triangles. All right, and there are 3 methods we're going to use to do that. Okay, the first method is what we talked about yesterday and we talked about in our warm-up is side similarity. This is when the ratios of all corresponding sides, and I'm going to abbreviate corresponding like that, are equal. All right. You can pause it to write that down. Our next one is going to be side similarity, where I have 2 pairs of corresponding sides. With equal ratios. And a congruent angle in between. Remember between BWTN. Okay. Our last method is just by the angles. Now this third method I will mostly use for proofs. Okay, yes, proofs are coming back today. This is our proof day. I told you we'd have one second semester. All right, so there's angle similarity, which is just 2 pairs of congruent angles. Okay, so having said that, let's try a proof. Okay, let's try a proof. I wish I was there for this because boy do I love proofs, right? I just want to do a quick little review. Remember when we talked about proofs last semester, we talked about parallel lines. Okay, if I have 1, 2, 3, 4, 5, 6, and you don't have to write this down, just watch. 7, 8. Remember that there's a lot of different types of angles. Like 2 and 6, those angles are corresponding. Okay. 1 and 8, those angles are alternate exterior angles. 4 and 5, those are alternate interior angles. Okay. We also had same side interior, like 3 and 5. We had same side exterior, like 1 and 7. Remember that angles like 2 and 6 are corresponding because they lie in the same position. Okay. 4 and 5 are alternate interior because they alternate on opposite sides of our transversal. So having said that, let's look at this problem here. Let's look at this proof. Oh boy. here we go. So I got 1, angle 2, angle 3, 4, 5, 6. Okay. I'm going to write down A, B. Remember the 11 means parallel. Okay, step 2. All right. There's a couple different things I can prove here. All right. So I want to find 2 pairs of congruent angles. Well, there's more than 2 pairs of congruent angles in this picture. Okay, but I only care about 2. All right. So I can say that angle 2 is congruent to angle 5 here and here because of parallel lines. So definition, parallel lines, and those are alternate interior angles. I could also say that 1 and 6 are congruent. Okay. Those are also alternate interior angles. Okay, but I'm going to choose, because I like these angles, I don't play favorites, but I like this a lot. Angle 3 and angle 4, because they are vertical. Don't forget about vertical angles. All right, vertical angles. In this picture, I'm going to go back to that last slide in a second, like 5 and 8 are vertical, 6 and 7 are vertical, 1 and 4 are vertical, 2 and 3 are vertical. Okay, so I'm going to use 3 and 4 as vertical angles here. Okay, if you said 1 and 6 in this third step, that would not be wrong either. Now, if I'm thinking about proving, remember this little single squiggle means similar. I'm thinking about proving that these 2 triangles are in fact similar. Okay, I need 2 pairs of congruent angles. Well, I have that. There's 1, there's 2. So now I can say that triangle ABE is similar to triangle DCE by angle similarity. All right. So if you look at a problem like this, okay, now we could see, I'm sure you could tell that these ratios are the same. Okay, so what type of work would I need to see for a problem like this? I would need you to show me that the ratios are equal. Like 8 over 2 is 4, 12 over 3 is 4, 10 over 2.5 is also 4. So are these triangles similar? Yes, they are. By side similarity. That's the type of work I would want to see. Now there's a chance that they aren't similar. There can be that case. Okay, then you say not similar. That's all you would have to write. All right. If they weren't similar, let's talk about that. All right, let's say this was 10 over 3. Well, that's not going to be 4. Okay, that's not going to be 4. All right, that's going to be like 3.33 repeating. If that's the case, then these would be not similar. Since that's not the case, they are. All right. Now for this one, I want you to pause the video and I want you to see, is PQR similar to VWX, or is STU, triangle STU, similar to VWX? So pause the video and let's see. All right, so for this one, you could have done it a couple different ways. I could test the ratio of the sides. So I could sit here and say, all right, if I say STU, okay, and VWX, like I could test 30 over 12 and 20 over 8 and see if that's the same. Okay, 30 over 12, if I divide those two by 6, I get 5 over 2. If I divide these two by 4, I get 5 over 2. So that checks out. So STU is definitely similar. Let's just double check to make sure PQR is not. 16 over 12, divide them by 4, I get 4 over 3, and 12, well, buckets. Okay, 12 over 8, divide them both by 4, I get 3 over 2. So that is a case where it's not similar, so that would not work. So what I would say is triangle STU is similar to triangle VWX by SSS similarity. Okay. What I want you to do the rest of the class, there's a second packet. Okay, I want you to work on that. You could probably get that finished. All right, knowing that this video is pretty short. When you're done with that, please find something else to do. Sorry I couldn't be here today. I tried to come in, but it just was not happening today. That packet is not going to be due until next block period. I don't want to give you any homework over the long weekend, but you can finish it today. Okay, you can finish that today. That way you don't have any homework when you come back. All right. Have a great long weekend. We'll see you.